When you're transforming your object, you have access to multiple coordinate spaces. It's best to use the appropriate coordinate space for the task at hand in order to make whatever job you're doing at the time much easier. So in this case, I have this object, and it really doesn't necessarily matter where how I'm moving this, because I just wanted to move this maybe perhaps at this location. But at times, you may want to move along your object's local orientation, so you need to make sure that you use the correct coordinate space for that. So in this case, if I went up here and switched to local, my transform gnomon now aligned to my local space here. So now a transform that might have been more difficult in the view transform coordinate space is now easier in this space. So if this is a move that I needed to do along my local z axis, it would have been a lot easier to switch to this coordinate space. Now, the different spaces you switch to will also change the what you have access to, or what values are visible within that space. So if I go ahead and switch to, let's say, a world space, you can see now I'm able to view my world coordinates here. So since I'm in transform, I can go ahead and bring this down and just zero out within this coordinate space, within the world space, and we snap to our origin. So each space is meant calculates information in a different way. So if we go to view, the way this works, any perspective view will default to a global world space, and any view that you activate will have Y going up and down in screen space and X going left and right in screen space. So in this case, everything is aligned. All my gnomons are aligned to world, since perspective is my active view. And if I switch to this view here, you get to see now Y is up and X is left and right. And this is how screen space is calculated. So if I go to each view, you get to see Y up and down, X left and right, and that's because this particular view is active. And if we look at our left view here, we have our Z and X, or Z and Y, and the second I go inside of the view and activate it, it now switches to Y and X. So that's what the view is. It's a hybrid view, hybrid between screen space and any orthographic view, and world space, world coordinate space within a perspective view. The next view we'll look at is just screen space. So regardless of which view I'm in, you get to see all of my transforms are within screen space. And as I rotate my camera, you get to see that the Y is always going to be pointing up and down parallel to this line here, and X will also be parallel to the bottom of the viewport. World space, everything will be aligned to my world gnomon. So if we look on the bottom left at our world compass, everything will be referenced to this world coordinate space, regardless of the orientation of my object. So if we grab the orientation and rotate, we see the gnomon stay still. Parent space your current object will reference its current parent space. So in this case, this cube doesn't have a parent, and it's automatically going to reference the world space. So if I were to just go to local real quick, make a object to parent to, we'll create our link. Okay, so now we're in grid space. Let's go to parent orientation. So now, in this case, this object's orientation is going to match the parent, and if I were to select the parent's orientation is going to match the world. Okay, so that's the parent orientation. And it might look, so if I were to go ahead and rotate this up, like so, if we look at the parent's local, this is the local orientation for the parent, and if we go to the child, parent, it's taking the parent, even though the orientation for the local in this case is the same. So if I were to flip this like so, you got to see, since we're in parent, even though I rotated my local object, it's taking the parent's local orientation. So that's parent orientation. Local, we've been using this as a reference. It looks at the current object and how it's oriented as the local space. Gimbal. Gimbal will take, it's similar to our parent, and it doesn't necessarily, essentially, when you're working with Euler rotations, whichever the middle axis is within your rotation order will be the axis that will create gimbal lock. So in this case, it's similar to, let me go to gimbal again. So if I go ahead and rotate my axes, you see X and Z, they rotate just fine, but the second I go in the Y-axis, the X-axis moves along with it, and this is going to cause gimbal lock. So now I only have access to 2 of my channels, and I've lost access to my X-axis here. So that's your gimbal orientation. Gimbal will allow you to work within the Euler transform space more predictably. So we'll move on to our grid space here. So grid, you're able to make helper grids, and your default grid is your home grid, which is on the bottom. So if we go to create helpers over here, we can create a grid, and this will become our new working space once it's activated. So if we right click on our object, we can activate grid. Our home grid disappears, and this is our grid space now. And if we go ahead and switch this to grid, now since this is our active grid, we can transform our objects along our grid space, whichever grid is our active grid. In this case, it's this one. If we activate our home grid, this is now the active space, and if we were to select this, our orientation, our gnomon is now oriented to our home grid, and that's the grid orientation. Working grid, every object has a working pivot, an object pivot and a working pivot. That can be changed here under our hierarchy. So if we go edit working pivot, you get to see this is the working pivot for this particular object. So if we switch this to working, we're able to use our working pivot for our object. Pick will allow us to pick any object and use that picked object's coordinate space for my current transform. So if we go and let's create a new standard box or sphere, we'll grab a sphere. And right now, if we switch this to, if we pick this object, I'm able to transform the sphere along the box 002's coordinate space. So even though the sphere's local space is here, I'm able to move the sphere along the box's local space, which is here. Okay, so those are our different coordinate spaces.